Yes, good morning students. Today we are going to discuss IIT-JEE NEET Foundation. See, the topic is electricity. So, electricity is very important in our daily life. Yes or no? So, electricity, electrical instruments, without electricity, see, now there is very difficult to live on the planet. That's such an environment we are living. So electricity, electrical instruments. We are going to discuss the study about charged bodies, charged particles is called electricity. There are two different branches in the electricity. First one is static electricity, another is current electricity. Study about charges are at rest is called static electricity. Study about charges are at motion is called current electricity. Static electricity is also called electrostatics. Current electricity is also called electrodynamics. So charge is nothing but if an electrons, usually all matter is made up of atoms. Atoms consist of, there are so electrons, protons, neutrons, electrons revolving around the nucleus, all these things you know. So there is some excess of electrons or there in the body, that is called as negatively charged body. If there are some deficiency of electrons or losing of electrons or less number of electrons are there, so that is called positively charged body. So basically charge is, it's a important property, like, okay. So see, in the electricity, the electrical elements, electric charge we are going to discuss. The unit of charge is coulombs. The unit of charge is coulombs. Charges are two types. So, or you can take a neutral charge also. First one is positive, second is negative charge, third one is neutral charge, of course. Neutron, proton, the charge of proton is 1.6 into 10 power minus 19 coulombs. Charge of electron is also same, but the charge of electron, so the negative value should be taken here, minus 1.6 into 10 power minus 19 coulombs. So basically charges are characterized by the some, what are the characteristics of the charges? The characteristics of the charges is, charge is something, it is a quantized, means there is certain number of electrons, quantum of electrons. See, that's why charge is quantized. Number of, so total charge is nothing but n into, so charge of electron, Q is equal to Ne, it's a famous formula. So second is charge is conserved. See, charge is neither created nor destroyed. See, it is something transferring only. So that's why it is conserved. And the charge is something which is a scalar quantity, which is not having any direction. That you have to remember. And 1 coulomb of charge consists of 6.25 into 10 to the power of 18 electrons. See, a body can be charged by three methods, that is electrical or see, something like induction, conduction, so friction. So the frictional electrification is nothing but if a body is, see, charged by rubbing the two bodies each other, there is a transfer of electrons takes place, that is frictional electrification. Conduction, if there is a, see, high amount of charge is there, it transfers to the low potential areas, that is conduction. Induction is without any physical contact, if there is a transfer of charge takes place, that is induction. A body can be charged by these three methods, and charge always resides on the surface of a body only. Always it is where the where charge is located, usually on the surface. And like charges repel each other, unlike charges attract each other. See, like this there are many characteristics are there for the charge. So charges and the basically the rate of flow of charge is called current. The rate of flow of charge is called current. And when substance allows the charge through itself, that is called conductor. If the substance does not allow the charge is called insulator. If the substance allows partially through the, see, through itself is called semiconductor. So conductor, semiconductor, insulator, these are the three types of materials, like metals, like, see, conductors are, see, Examples, all metals are good conductors like gold, silver, aluminum, etc. See, semiconductors, germanium, silicon, etc. are the semiconductors. Next one is insulator. Insulators are which doesn't allow the charge through itself are called insulators. Insulators are, see, rubber, plastic, etc. are the insulators which does not allow the charge. Coming to the fundamental properties of the matter, it is a charge is a fundamental property of the matter. You can understand. So here depends isolated charge, single charge if it is there. So which is having only single pole like electrical monopole, electrical dipoles, quadrupole, conservation of the charge. I told you just now. See, electric charge is conserved, electric charge conservation. These are the equations, of course. So little, and this is about the introduction of the charge. Introduction of the charge. See, Coulomb's law. In the charges we have important law, that is Coulomb's inverse square law. What is Coulomb's inverse square law? The force between two charges is directly proportional to product of charges and inversely proportional to square of the distance between them, acts along the line joining between two charges. See, let us take Q1 and Q2 are the charges here. Q1 and Q2 are the two charges. Those two charges having a force. The force of repulsion or attraction, because either it could be attractive force or repulsive force. Attractive force, if positive is there, that is repulsive. If positive and negative is there, attractive force. See, here there is a force exists between the two charges here, Q1 and Q2, and they are separated by certain distance. The force is directly proportional to product of charges. See, Q1 into Q2, F is equal to Q1, K into Q1, Q2 by R square. See, the K value here, the K value is called proportionality constant, that is 1 by 4 pi epsilon naught. See, Q1, Q2 divided by 4 pi epsilon naught R square. See, epsilon naught is nothing but permittivity in the free space. Permittivity in the free space. 1 by 4 pi epsilon naught value. 1 by 4 pi epsilon naught value, that is 9 into 10 power 9. 9 into 10 power 9. The value, it is Coulomb square by Newton meter square. See, this is the value of 1 by 4 pi epsilon naught. Coulomb square by Newton meter square. It is a proportionality constant in the Coulomb's inverse square law. Of course, yeah, if you take epsilon naught means what? It is a permittivity. Permittivity is a property of a medium which describes the force between two charges. See, which is influenced by it. See, that permeability in magnetism, permittivity in electricity. These are properties of medium. So from this you can understand the, see what medium where these charges are located. So if it is placed in water, there is a permittivity values are different. How can you take that? See, for that you can understand here the 1 by 4 pi epsilon naught value 9 into 10 to the power of 9. So before that we will do some sum here based on this Coulomb's inverse square law. Let us take the value of Q1 here. The value of Q1 is 30 into 10 power minus 6 we will take. The charges you can take, see, minus 6. Here, see, Q2 value, if you take 10 into, see, 10 power minus 6. And the distance is, the distance between two charges. The distance between two charges is, see, let us take 20. So only will take 20. See, then force exists between these two. See how to find force. See, this is the value 0.674. 0.674 into 10 power minus 2. How you got this? Just we will calculate according to the formula. It is same only. Just simply we will calculate to just prove it. See here F equal to 9 into 10 power 9, K into Q1. Q1 value is 30 into 10 power minus 6, and Q2 value is how much? 10 into 10 power minus 6. Upon distance is 20 square, 20 into 20 you can take. If you simplify this, so 9 3 ja 27, 2700 you will get 2700 into 10 power 9 into 10 power minus 12, that becomes 10 power minus 3. So upon it is 400, 20 into 20 is 400, 0 0 get cancelled. See if you cancel it, see 4 6 ja 24, 4 6 ja 24, 3 will come, 4 7 ja 28, approximately 6.7 into 10 power minus, so that is the same value which is going to be there here. See 6.7 into 10 power minus 3 newtons. It is approximately 0.67 into 10 power minus 2. 0.67 into 10 power minus 2 newtons. See both are coming same. It means, see by changing the values of charges you can also find the force between two charges. You can find like that. The electrical force examples you take. 1 second worth of charge from 120 watts light bulb. So this is minus 1 coulomb, you can have, this is one example, 1 million tons of repulsion will be there. So 120 watt bulb if it is there in daily life examples, how much force of repulsion? 1 million tons of repulsion will be there for one, when you compare with 1 coulomb charge. 1 coulomb charge when you compare with that, so this much difference will be there. So that's what he is explaining. Coming to the more on Coulomb's constant. Coulomb's constant is, that is 1 by 4 pi epsilon naught is equal to 9 into 10 power 9. So this value if you try to find out, see Coulomb's constant into, see charge of electron square, Ke square. The Ke square value is this. These are also some important values which we use in the modern physics, electromagnetic spectrum. There the values we are going to use. This is 1.44 mega electron volt joules. That is also important constant. In later physics you are going to learn all these things. Thank you very much. Thanks for watching this video.